Okay, so let's talk about the panel. So this is our closing panel for the day, making OFED a fit for cloud and virtualization. So we've had a lot of good topics today. Actually, I was really encouraged with how things went down today. We had a lot of very good discussions and a lot of, Paul said it, I agree, there were a lot of ahas and new points that came up, and that's exactly what we're asking for here. So now we get to try to put it all together and debate it. I picked this team of panelists here, and I want this to be interactive. So I'm going to show just a couple slides. So first I want to introduce our panelists here. Dave Durkee from ENKI, Paul Grun from System Fabric Works, Ronald Luijten from IBM, Josh Simons from VMware, and Jake Smith from Intel. Okay? So here's my one slide. And this was the slide that Jake, stole from me, so I'm stealing it back. And I want to say, and I will present it my way this time. And I'll say that, the world is changing when we look at cloud. What we did on the past is all these purpose-built, installations from the hardware all the way up to the software, and now it's going to be moving to the right-hand side of the picture, where we're going to have applications and software that are running in a environment where it's a conglomerate of hardware that you don't know where it is. Okay, and what's important about that as fabric guys is that we've got to make sure that fabric underneath there is capable of doing everything up top. So, I think this really sets up the need for, we heard it many times today, converged networking, being able to run all the different protocols, et cetera, et cetera. And so that's the mindset here. That's what we want to focus around, is the network piece of bringing this to cloud. So I don't want to talk too long. I want these guys to talk. These guys are the experts. So I had a list of questions that I ran by the panelists ahead of time, and I think almost all these questions were asked, or at least answered by one of these guys earlier today, or some of the guys up front. So I spent the last half hour trying to come up with some better questions. And I want to ask the audience too. So I'm going to walk around with the mic, or ask Bill to walk around with the mic. But in lieu of that, I prepared a few so we can kick them off. But I'll start with the first one here. So because a lot of the questions on the previous slide are what kind of things have to be done, or can virtualization be used to do this? And I heard it over and over. The virtualization is a key element here. So one of the things that's obvious to me is, for adoption to begin, we need RDMA support in a virtualized environment. But I think the question is, how do we get there? So that was really the question. What are the next steps? And I think we as an organization need to hear that from these guys and figure out what actions we can take to make progress. So anybody want to start? I'll just pass the mic around.
Okay, I'll start with answering question number 4. Is it 4? 3, okay. So I don't remember if at this crowd I presented once the performance analysis work that we've done for HPC fabrics. And to give a quick summary of what we did is we took traces from various HPC applications that we got at the MPI API layer by inserting a shim layer and basically capturing the launch times of packets, the source destination, protocol, the length, etc. And we use that to play back those traces into our simulation of the entire network. And doing that, we actually changed the state of the art in HPC. There were times where people in HPC were saying, I just need to double the bandwidth, and I double the performance. And what we were able to show is to say, you can sometimes increase the bandwidth or the effective use of the network tenfold without adding any additional bandwidth in the actual network, by understanding how you can maximally use those things. So the argument I'm making is going to the answer, what tools and monitoring capabilities are required for success, is that bandwidth is really the scarce resource that we get in our data centers. If we want to effectively use that bandwidth, we better understand how it is used, or where things are being congested or being blocked. And congestion control is one thing, avoiding congestion is much better. So my argument is we should build monitoring capabilities as part of the hardware, like what we did in HPC in the MPI API layer, but put that into the hardware in the NICs not in the switches. The switches doesn't scale, and allow that to do a performance analysis of the network. And the best is to tie that into the management of the network, so you can really efficiently start to use those resources. Any comments?
That notion of being able to manage congestion of the network, I think, is very similar to where I was going in my last presentation with a centralized fabric manager. If you know, excuse me, where the hotspots are in the fabric, you can route around them. So the ability to identify those hotspots is one thing, and then the ability to do something about them is another, and we need both of those.
We just bought a tool from Mellanox or Voltaire, actually, and I forget what it's called. It's a fabric manager for IB that effectively does this for us. What we saw was that we have no idea what's going on inside our IB network. Sometimes it works, and sometimes it works really well, and sometimes it doesn't work so well, and we have no idea. We bought some 4036Es. It's a QDR 36-port IB switch with 2 ports of 10 gig each. We plugged that into our existing switch fabric, and everything froze. Nobody knows why. So and it took our entire network down. So that's the kind of thing that I would really like to understand. So I would need a tool to understand what's happening at the detail level, to understand what's happening, how do I fix it, how do I prevent it, so I can do a root cause analysis. I believe that this new software that they have, I forget the name of it, QSA or something or other, or VSA or QFM. Yes, QFM should solve this problem for me. UFM, yes. So we're just getting smart on it, so I think we need more tools like that.
Yeah, and I think that's exactly where I was lining this question up with. You know, we got a lot of IT folks, they're doing data centers today that become cloud folks now and in the future. You know, what are they used to having tool-wise that we're lacking today? Because I think we need to know that and get, work a plan to develop.
Well, I actually agree with my fellow panelists, but as a silicon guy, I think it actually needs to go one layer below. And I actually think that one of the things that we need to do with the tools is we need to make them even more intuitive. One of the things I constantly see is that we say we have tools and we say, oh, well, here's command line tools for system administrators to use. The reality is system administrators on the whole don't use a lot of command line tools. And so what we find is that we can't diagnose the problem because we don't either have a language capability inside of our IT shop, or we don't have an understanding of the tools that exist. And so even though these tools exist, whether it's a unified fabric manager, whether it's some kind of VMware system interface capability, we don't do enough on the education side. So do we need these tools? Yes. Do we want to identify the hotspots? Absolutely. Do we want to architect networks that scale and are dynamically accessible? Sure. But if we do it so that we have these command line interfaces that require us to try to seek out user forums in order to find our solution, I think we leave the industry back where we started. So we have certain tools where top-end operators, whether it's system administrators or architects, know how to fix it, but yet the everyday system administrator is struggling with how do they manage their hotspots. So I would actually like to see folks like VMware really push, because you guys can do a good job, because you can make that link with vCenter, you can make that link with DRS or the Dynamic Resource Scheduler for those of you who don't use it. Really start to push the industry, us, on the silicon and on the hardware side, to actually expose our instrumentation in a way that we create drop-down menu capabilities so that system administrators don't have to know command line as well as drop-down capabilities, and simplify. And that way we can take advantage of some of the things the other panelists talked about. But until we get there, we're at such a low level that we're sort of leaving it for the few and the folks from Lawrence Livermore and Oak Ridge to figure out, and that just doesn't create enough scale for us to continue to innovate, in my opinion.
Sorry, I guess the only thing I would add is, yes, absolutely, instrumentation needs to be exposed, but actually at the scale that we're thinking about for cloud and certainly for high-end HPC, we're getting to the point where monitoring tools is probably a limiting term in the way we think about how we're actually going to diagnose issues. I think this actually turns into what I'd call an infrastructure big data problem. There are going to be massive amounts of telemetry coming off of the interconnect and off of other pieces of the scaled-out infrastructure, and things like machine learning and other tools are actually going to be quite important for diagnosing these issues, having automatic pattern recognition techniques, for example, looking for anomalies in the fabric, for example. So I think there needs to be some thinking about how we're going to go to the next several orders of magnitude of complexity when dealing with these sort of issues and moving beyond sort of vanilla monitoring capabilities.
How about a question from the audience? Anybody? Shout it out.
One concern is security, yes, virtualization and security. Virtualization opens for us the new areas, new lands, but today we don't know what holes, what security problems we can meet in adoption. For example, the security on the line. So we have the Rocky. Rocky is based on Ethernet. So when the user wants to encrypt the traffic, yes, what we can choose? So we can use, for instance, the IPsec, but we have now the IP layer. So we can use MACsec. MACsec is fortunately L2. It is one concern. The second concern that I have is fault tolerance. Rocky, iWarp assume lossless Ethernet. So for today, in the real world, there is no such thing like lossless Ethernet.
So I think I heard security and failovers or lossless. Anybody? Did you raise your hand?
I'll get it over to Paul in a second. I think it's really, for me, it's two things. Number one, I think we should begin pushing the idea of encryption everywhere. Obviously, Intel has some advanced encryption instruction sets. They're good. I don't think they're enough, and I think it's ongoing. I also think that when you look at the things that we're doing in the future, we're doing some things with some advanced number generating features. Excited about that. I think we need to continue down that path. But with virtualization and cloud, we're increasing the surface area. It's obvious, right? I mean, you're just increasing the surface area for attack. So we have to be diligent in what we do, and we have to partner with each other to ensure that we're closing the holes. It's just that's, to me, there's no silver bullet. Okay, it's ongoing. As soon as we think we have the silver bullet, somebody's going to find another a place to pierce it. And then on your second question, I don't know that I have a good answer for that, so I'm going to hand it off to Paul.
You are now obligated to answer that. Should I start with the second part? To your point about Rocky and whether or not it drops packets and iWarp and so forth and so on, to be quite candid about it, one of the precipitators behind the idea of Rocky was the emergence of a lossless Ethernet. And the thinking was quite specifically that the InfiniBand transport works really, really well in an environment where packets are not routinely dropped. So when the Ethernet community started talking about lossless Ethernet, it created a great opportunity that says now we can run more efficient transports over that wire. You can run Rocky over a standard Ethernet. How well it's going to work, I think, is open to debate, particularly as the fabric gets over-provisioned or gets close to its provisioning level. But running over a normal, DCB-enabled network, it should work extremely well. That'd be my guess in terms of reliability. I don't know if that answered your question or not. That was a little bit different than you actually started talking about fault tolerance. And that was one that was sort of in the back of my mind. I'm thinking about automatic path migration in IB, and do we need similar capabilities like that in iWarp and or Rocky? Was that part of what you wanted to talk about? Being able to fail over to different paths through the fabric? Is that where you were going?
For example, we are using spine.
I can't hear you. I'm sorry.
The mic is here.
There's only one mic, sorry.
Mic runner.
I bother one thing. You told in your presentation that, for example, you use for routing L2 traffic the spanning tree. You can imagine how long it takes the reconfiguring the spanning tree in large network. So I think it is seconds. I can't imagine the fault tolerance with the spanning tree. Yes. For instance, in IP, when you use the OSPF, for instance, it is much faster. And with L2 and Rocky, so for example, you can't use this. So in IP networks and iWarp, it is much, it's maybe not ideal, but I think it should work much better than the spanning tree, for example. Yes, so in large networks.
So I think you and I are of one mind about spanning tree, which is why I coupled together that, my high density server with a more efficient centrally managed network where you really can handle fault tolerance better. And that applies equally to iWarp and Rocky. It is not specific to Rocky. It's specific to, not using the spanning tree protocol if fault tolerance is your goal. The other point you raised, the first question you raised about security, I just wanted to raise a little bit of a red flag about that's a topic that needs to be approached very gingerly. And the reason is because it'd be very, very easy to wind up with an incredibly overburdened wire protocol that's intended to create security that actually doesn't create really good security but really reduces performance immensely. And we need to be careful about that, to define what we're trying to do with security before we start monkeying around with the protocols to make it work. So just a little warning there about that. Anybody else?
Yeah, just a little bit on fault tolerance. So there's a general trend that fault tolerance, so more generally resilience in the system, is being addressed at new paradigms of programming. So in fact, when you look at Hadoop or MapReduce, one of the great features of this method is that it deals with one of those clients simply just going away and not providing results, right? So the other ones take over, and as a user, you actually don't really get to notice this. And you saw also with IBM's presentation on PureScale from Steve that lots of software is taking care of how to build a resilient system, of course in conjunction with hardware. But there is a big trend going away from hardware does everything and software doesn't have to count with this. It's just cheaper to do this in software these days. And this will continue.
Any other questions from the audience? Yes, one.
So I'd like to draw attention to the bullet point 2 about the need for new APIs for OFED in the cloud. Are there any requirements for verbs that don't do, say, only transfer data like at a very low level, but also do something much more higher level, like collect statistics and things like that, so that these tasks can be offloaded onto the network itself? So does any one of the panelists have some thoughts on the second point? On like improved more intelligence, like you want to give the network more intelligence and like have the switches or the HCAs try to compute some information, not just give you all the like the raw information that, I dropped so many packets, this packet was dropped, because as Josh pointed out, that quickly this data can, explode.
You want to try that one first? Okay. Okay, yeah, it's kind of a thorny issue, right? I mean, you're talking about a transformation of the way data has gone from structured to unstructured data, and how do we manage unstructured data in an open fabric, and how do we connect those APIs? I think that's a big issue from where we sit at Intel. I know it's something that we're talking about from the development side on a regular basis, and we're looking around the ecosystem for partners to help us address that issue. I don't think we have an answer. I don't think we're going to sit up here and say, oh, we figured out how to, manage the big data, big unstructured data issue, and all you have to do is buy an Intel processor. Or, no, I don't think it's that at all. I think there's a lot of, I think once we do 4 or 5 years of research and actually develop products to deal with this unstructured data issue, we're going to realize that the data sets are much bigger than we anticipated. They're growing much faster, and we're actually going to have to speed up our development to stay in touch with the amount of unstructured data that's going on in the market today, and actually build, as Josh was alluding to but not really saying, some of those engines that start to be intelligent about the way they look at unstructured data, and whether it's Hadoop, whether it's some other dynamic optimized file system that exists in this unstructured data world. I think that's something that we have to be careful of and spend a lot of time on.
Okay, any other questions?
So this morning there were a couple of presentations, or maybe there was more than a couple of presentations about the data center and how it has Ethernet, but it doesn't have InfiniBand, how the admins really don't know how to manage InfiniBand, et cetera, et cetera, et cetera. So I'm sitting here, I'm a new guy coming for the first time, and I'm basically asking the obvious question: how many of those data centers would adopt Rocky as a solution and just use one Ethernet fabric for everything?
That was the exact motivation for Rocky. If you think about it from an RI perspective, there's a lot of return to be had from RDMA capabilities, but for some people the investment of moving to RDMA was very, very high. So the whole motivation behind Rocky was to reduce barriers to adoption by reducing the investment required, by letting people harvest some of the benefits of RDMA over their existing Ethernet infrastructure. So I think we're thinking the same way, at least I hope so.